So, Paul, we've been looking at how to find planets around other solar systems or in other solar systems. But it strikes me that in our own solar system, we have lots of stuff. We have lots of little things like comets and asteroids and things we don't call planets anymore, like Pluto. Wouldn't it be possible if there's lots and lots of those things to maybe see those around other solar systems or in other solar systems?
Well, that's what we're going to talk about in this lesson. Is it actually possible to see the small stuff? And it turns out they were actually discovered before the big things, which is a bit weird. You'd think big things would be easier to see than small things, but all will be explained. It all started back in the early 1980s with the IRAS satellite, which was a joint venture between NASA, the Netherlands and the UK. A little tiny satellite by modern standards. Basically, to work at infrared wavelengths, you have to have the telescope very, very cool. So this thing is basically a great big, we call a Dewar flask full of liquid helium, which kept the whole thing at an incredibly cool temperature, and it surveyed the entire sky.
Yeah, so it was really the first of its generation to be able to go through and map the entire sky, and it quite revolutionized our ability to do astronomy at these wavelengths, because from Earth, you can see through the atmosphere, but it's so bright because the whole of everything that's warm glows at infrared, so it was able to get around those problems.
Yes, it actually triggered off a whole great conspiracy theory, kind of by mistake. Just like we talked about quasars, when they discovered the first big radio sources in the sky. They didn't know what they were. It turned out to be the quasars. When we now had the first infrared map of the sky, they discovered a number of incredibly bright infrared sources, and they couldn't see where they were coming from. So one theory they put out a press release back in the early 80s was, in fact, it might be a second star in distant orbit around our own that came near every now and then and devastated things.
Oh, sort of nemesis or something.
Yes, and they put out a press release about that. Then about a month later, they discovered that, in fact, these were distant galaxies, what we now call ULIRGs, ultra-luminous infrared galaxies, a galaxy which was forming stars at an incredible rate with huge amounts of dust. And so they said, sorry, we made a mistake. But of course, the original press release got all the coverage and the retraction got nothing. And to this day, at least until 2012, people believed in this killer star, and that IRAS had proven it was all part of a conspiracy to hush it all up.
So I take it IRAS found more than just ULIRGs.
Yes, and there was one thing that we knew already existed, but they didn't expect to see, which was Vega, one of the brightest stars in the sky.
And one of my favorites, it turns out.
And Vega is a hot star, so it should emit light at visible wavelengths, which is this dashed line here. And it does emit light at visible wavelengths. You can go out to the night sky and see it for yourself. But what they expected was lots of brightness at the visible wavelengths, then dropping off to essentially nothing into the infrared. What they actually discovered was dropping off, and whoop, it went up, and actually was extremely luminous at the infrared.
This is a bit of a problem because, the reason this is one of my favorite stars is because it's one that I go through and use to tell me how bright all the other stars in the sky are. And now you're telling me it's got all this extra stuff we don't understand. Makes me wonder whether or not we have these numbers right as well.
Yeah, it turns out it's not a very large fraction, but its luminosity in the infrared is about 2.5 by 10 to the minus 5 times the luminosity in the optical.
Okay, so using kind of funny units here. So
Yeah.
although this looks a lot smaller than that, this really is a lot more energy.
Yeah, this is strange radio astronomer units where they emphasize things at long wavelengths. So, what could be going on here? The obvious idea would be that maybe there was something nearby Vega, so close we're not separating it out with a telescope, and the IRAS satellite had very poor resolution, so anything vaguely nearby could be part of it. Maybe something like a planet.
Ooh.
And the light from Vega is heating up the planet and making the planet glow in the infrared. We've already talked about these things glowing at the infrared, so maybe what you're seeing is Vega here and a planet, because 2.5 by 10 to the minus 5 doesn't sound like much.
Well, that sounds like an easy calculation to do.
Okay, so let's work out if it actually feasibly work by having a planet nearby.